Patrick Chansa. I'm coming from Control Center. Our table we have introduction, departmental structure, ventilation section, local mechanics section, system engineer section, geology section, survey engineer section, blasting section, and mining section. We also talk about mine designs and our mine method here, we'll talk about it. Control Center is a technical department which is the most important department in any life of the mining because it provides technical expert, planning support to ensure efficiency, safety, and sustainable extraction of ore. Our department typically handles tasks such as geological assessment, mine design and planning, and also monitor of mine operation. We also develop technical reports, optimize mine process, and ensure compliance with safety and environmental regulations. Overall, our technical department plays a critical role in guiding the technical aspect of mining project to minimize productivity while minimize risk. This is our departmental structure, how it is under Control Center. On top, we have assistant superintendent, it's our bigger boss. Then followed by departments, which is about 7 departments. The first department is the geological department, which has geological engineer, then geological foreman, geological technician, and also samplers. We also followed about mine engineer section, which have mine engineer, mine foreman, mine assistant foreman, and mine technician. And followed about ventilation section, which have ventilation engineer, ventilation foreman, ventilation assistant foreman, and ventilation technicians. Followed by blasting engineer, which have blasting engineer, blasting foreman, and blasting assistant foreman. Then we have local mechanics section, which have local mechanics engineer, local mechanics foreman, local mechanics assistant foreman, and local mechanics technician. We also have system section, which have system engineer, system foreman, system administrator, fuel attendants, dispatch, and drivers. Then lastly, we have surveying section, which have surveying engineer, surveying foreman, surveyors, and survey assistants. At this time now, in our department, we have total number of people of 105. We talk about the ventilation section. This is a section that monitor and control the flow of air underground. We monitor 4 mine ventilation shafts for inflow and outflow of air, which is service shaft, main shaft, north ventilation shaft, and south ventilation shaft. We also control the airflow underground by installing vent fans and vent tubes to have cooler air in the working place. We measure also amount of gas underground, such as carbon monoxide, carbon dioxide, and so on. Some of the instruments we use to measure air and gas by ventilation underground. We use wheeling hygrometer, which we use to measure the amount of temperature underground. We have also Castra, the instrument used to measure dust sampling. We also have gas detector, instrument used to measure the level of gases. We have also dragger pump. This instrument used to measure sample diesel emulsion on diesel machine, and it also compared with test tube of the gas intended to test it. Venometers used to measure air velocity in working environment. Buffer is used to show the direction of airflow. We go under local mechanics section. This is a section that deals with the structure and the behavior of the lock. And it's a critical section because it deals with safety of workers. The duties of local mechanics. One is to conduct put test. It's very important. Make sure that daily they conduct put tests. Also, to inspect the structure of lock and give recommendation of type of support to use. Monitor the quality of support underground if it's up to required standard. Install lock monitoring system, which help us to monitor if the behavior of lock on the surface. We monitor the lock, how the lock are moving underground. Do support counting and inspection with contractor. The type of support we use underground. We use welded wire mesh, split set, cable board, roof board, and backfilling. This is how we store wire underground. This is, as you can see, there is welded wire mesh there where they point the arrow. Then they also a split set. This is how we store the wire underground. This is the design. As you can see, this is a section design where it shows split set installed. Split installed like this section. This is a plain section for welded wire mesh, how it look like. This is a cable board and also roof board. Then cable board mostly we install in T-junctions and also in the stops where we install cable board. This is the instrument used by lock mechanics to do pull tests. There are two different instruments. The one which is in yellow is the new one. It came a few months ago. This is how we store steel arc and timbers, and also concrete shattering support. In some cases, where we find the pillar is speeding off, we install concrete shattering support. Also, where we find the lock is falling too much, here is too much crack in the lock, we store steel arc and put timbers there. System engineer. This is a section that deals with control and monitor of system of water, backfilling process, diesel, and electricity in our mine operation. These are the group that's in charge with almost all mine operation. The duty of system engineer is to monitor all mining operation underground, to monitor how water are flowing underground, to monitor backfilling process and and the building of backfilling ore, to monitor inflow and outflow of diesel, to inspect all pumps, water sample, and how pumps are working, to monitor how electricity is working in all mining areas. Joint section. This is a section that deals with identification of minerals underground and its mineral content. Duties of geology. We do identification of which is copper and waste underground before lashing. Conduct sampling and marking of geological boundaries. Take rock sampling from underground to lab for grade testing. Monitor grade control from underground up to concentrator. These are equipment and tools used by geologists. They use biological bag to carry tools such as hammer, compass. Also, we have chisel. We also have geological hammer, geological compass, measuring tape, paint and brush, sample bags, and bamboo sticks. Survey section. This section also is critical because it's the one that gives us proper mining direction. Duties of surveying. Marking ends, end preparation for drilling and surveying related, such as marking of offset to the face of an end. Dams, settlement and monitoring. Level and mapping underground and surface. Install number peg and set new ends underground. Shift monitoring and settlement, as well as subsize. Cathedral surveying. These are instruments used by surveying. There is total station, level, brush and paint. This is some of the instruments used by surveying. When they go underground, they always go with this instrument. Blasting section. This is the section, this is the one of the most important because it's deal with planning, design, supervising, and control of blasting operation. Under blasting, here at Southeast of Bode Mining, we have vertical drop, in which our partner, AECL, used to drop emulsion from surface to underground at 2 points, 680 meter level and 980 meter level. They use vertical drop to refill emulsion from surface, direct from surface to underground. The duty of blasting engineer is to provide mining activity with explosive through our partner, AECL, to monitor drilling of development ends and stops, to monitor charge and blast of development ends and stops, to provide drilling design for development ends and stops, to monitor safety and integration of explosive if it is followed. Type of explosive we use here at Southeast of Bode. There is bulk emulsion that we use to use on vertical drop, go underground, bulk emulsion. Then we use boosters, which is penthouse boosters. We use for stop. When we are blasting stop, we use penthouse boosters. Then we have stingers. We use for development ends. Then we have detonators. Then we have cobra code to help us for blasting purposes. We have magnum. Most cases, magnum we use at shoot boxes, loading boxes. We use magnum, most cases. Then you have spiders to plug the hose, the charged hose. Charged hose. For example, top hose, we plug with spiders. Then we are using new technology, the wireless, which is dead-shot langer. We have new technology we are using, dead-shot langer. We are using, this is wireless. This is the first drilling design and charge design. This is how blasting guys, they provide with design. How are we going to drill the ore and how are we going to charge the ore. This is some of the chart we use when you go underground, when we are charging the stops or timing plan. When we are timing the end or the stop, we use this timing. Blasting, they provide this timing. They give us the PIC or the blaster person. You follow this, you put numbers when charging so that the blast come out very well. My engineer section. I fall under this section as a mine engineer section. This is a section that deals with planning, design of mining layout, monitoring and inspection of section underground. The duty of mining engineering is to interpret stops design, development design, monitoring drilling of stops and development ends, monitoring beauty of backfilling ore and backfilling process, measuring of backfilling ore, monitor charge and blast of stops and development ends, inspect all other mine activities such as support standard and water sumps. Mine design refers to the engineering design of subsystem in the mine structure, e.g. drilling, blasting, haulage, transportation of works and supplies, electrical, power, water, ventilation, pumps, fuel system, ground support, reinforcement, stops and pillar dimensions. While the mine planning and design process express mining engineering contributes to the program, to the project, bear in mind in diversity range of other stakeholders, such as finances, geologists, metallurgists, administrative, and other personnel. Other personnel will be working on other aspects of mining operation plans and design process of same time. Type of mining design. We have mining layout design, we have development design, we have stope design. This is how mine layout design look like. This is for south section mine layout. This is another layout for north section. How they design the layout. Development design. Development design includes the following mine layout design: mine method, access drive and drift, ventilation, power and drainage, tipping area allocation, support design to be implemented in that particular area, such as cable board, wire mesh, and rubber boards. Other designs are important during development is a type of support that will be implemented as the development progresses. This type of support can be including cable board, wire mesh, rubber boards, just to mention the few. This is development design. There is some stops before being extracted. They have been mined by using development. This is the stop design. This is the downhole stop design. This is stop design, generally including layout of holes to be drilled, support design, charging design, and timing. This is the stop design. This is what you call a fan, like a fan design. This stop design of upwards. First drilling design. It's also called the development design or end design. First drilling design is carried out by either Boomer or Scientific DD4-221, which is an intelligence machine. Hence can be programmed to drill an end of non-profile on its own, while operators are just observing. Scientific DT4-221I is an advanced control system based on electrical hydraulic jumbo to provide top-level performance, accuracy, and the ability of underground development drilling and small-scale tunnels. Drill rig has the wide range of automatic drilling function to give increased productivity with reduced cost, top-level production, product safety, and access to future underground mine. This is how it looks. This is the Scientific DD4-221I. This is the Ultrascope Jumbo first drilling. This is the design for first design. So this one we give to operator to look, to see on this, and it drills exactly from this plan. Then here we'll talk about our mine method we are using here. In this representation, only cut and fill mine method will be discussed because it's the most applicable mine method of NFC mining. This is so in order to appreciate and deepen the understanding of operation of the company, as well as apply principles of each method in day-to-day mining activity, in order to standardize operation and improve on safety. Content fill stopping is the only method of underground support class that is common use in underground mine method today. There are three common variants of cut and fill, namely overhead and fill stopping, drift and fill stopping, and undercut cut and fill stopping. Cut and fill stopping method is normally used in overhead fashion, where ore is extracted in horizontal slicing, then replaced with backfilling materials. move from down most part of the whole body, going upward. Undercut cut and fill is done exactly like upward cut and fill. The only difference is the direction. So in which exploration is carried out, either descending or ascending. Drift and filling, 2 layers. This is a variance cut and fill mine method, which is usually used in all body of thickness of 6 to 15. This top is divided into upper layer and lower layer. The height of the upper layer is usually varied from 6 meters, around 6 meters. And then the remaining thickness is treated as a lower layer. Stop width sometimes can begin up to 9 meters. In this method, mine is first done with drift of upper layers. From top sub-level, then support it adequately with water wire mesh, split set, then cable bolt about 7 meters are grouted to reinforce the ground support. So this cable bolt to help to more reinforce the ground before we start doing stopping. After all, that is done at upper level. Long wells are drilled vertically down to the bottom sub-level in order to extract the remaining bottom layer, which is marked at the bottom sub-levels. Then the drilling holes are charged, starting with slot, until all the holes are blasted and mashed. Then the mined out stops is then backfilled with paste, with cement, mixed with cement. The picture below shows the sequence of drilling, of drift and feeding. This is a sequence of drift and feeding. So first of all, they start drilling, first drilling. So after doing first drilling, then they'll bolt it to support the roof with the cable bolt. Then after that, they'll start drilling tunnels and blasting. They'll create what you call a slot there. Get a slot there, a free face for easy breakage of wall when you blast. Then after that, we continue with charging and blast until we finish the stop. After that, we lash it, then we backfill it with paste. This is the 3D shape of cut and fill. Then secondly, slice and drift mining. Slice and drift mining is a modern variance cut and fill mine method. Like in the modern undercut cut and fill, the ore is extracted by first drift the upper layer until it reaches the end of the design. By then, the roof should have been supported adequately with wire mesh, split set, and cable bolt. Then instead of backfilling it before access the remaining ore at the bottom, drift resume from entrance like floor striping using the first drilling rig until the remaining ore is extracted fully. So as you can see the structure, we mine first like an end, then we finish, then we bolting. Then after we finish, then we come back here, start blasting here, going inside until we finish to the end. Then we backfill it. Upward fan long-hole stopping. Upward long-hole stopping is various long-hole stopping method where a stop are mined from bottom to the top with a blasting or drilling in fan-shaped pattern that extend upward within the ore body. In this method, mining is first done with drifting of down layers from entrance to the end of the stop in a development way. Then support adequately with folded wire mesh, split set, then cable bolt of about 7 meters are grouted into reinforcement ground support. Then start drilling the fan upward, from the end to the entrance, and blast it. That's how it is. We mine the lower part like this. Then the upper part we support it with cable bolt, with split set and wire mesh. Then after that, when we finish there, we start from the end there, blasting until we reach the entrance. Then after that, we backfill it. So as we end our presentation, in our department, it's very important to keep safety. We always work with safety. We always work with standard working procedure. Standard working procedure is whenever we are doing any work underground, there must be a procedure to follow. Then, also our section, we make sure that foreman, they do logging because it's a government required. Before the shift and at the end of the shift. What we have done, any place we have passed, and what we have not done, any safety measure we have implemented, we have to log in the logbook. Every day in the morning, we conduct pre-shift meeting to update our workers about safety. We conduct pre-shift meeting every morning. Before we go underground, we conduct pre-shift meeting so that we update about safety. In our department, we make sure that everyone will provide with PPE, personal protective equipment. This is our safety measure we put as our department control center. In conclusion, our control center technical department in this mine play a pivot role, ensure that there is efficient, safety, sustainable of mining operations. As the industry evolves with advancement in technology, increasing regularity demand, our technical department expertise became ever more critical in driving sustainable growth, optimizing resources utilization, and maintaining safety standards. Ultimately, the department committed to technical excellence and continue improving is essential for long-term success and responsible development of mining project. Thank you. It's the end of the presentation.